YouTube videos and the like. They're all just all over the place with videos telling us how the globe model works. Well, at least they're going to have to probably take a lot of these videos down. Please pay attention to this. This is their model, not mine. This is their model I'm using with my breakdown of this. Notice the winter solstice. The northern hemisphere is tilted away. Oh, this is one of the poorest diagrams there is. And in the summer, what? The north is tilted towards the sun. That's all you have to remember, okay? Why? Because we travel around supposedly to the other side. Oh boy. Let's take another look at this. This is a little bit better showing the tilt. North Pole, summer. Okay, northern hemisphere is in summer. Then we march around the other side, and then the south is facing the sun, and the light is on the other side. Correct? Yeah, that's it. So what causes the path? Now you can go see videos like this ad nauseum. Why does the path do this? You know why the path does this? Let's look and see why science and me both say the sun does this path, where it does this arc up in the sky and then goes down. It's lowest at sunrise, it's highest at noon, and lowest at sunset. Correct? Yes, that is correct, as long as this is the only thing you're looking at. Okay? You're in trouble, though, and science is in trouble if they look the other way, and they never do. They only show you from the northern perspective. Okay? Anyway, this video is probably good for a lot of you to get it down, because a lot of you don't know your own science model that you're trying to debunk. I mean, you actually look silly. I'm sorry. And after this video, before you make any other, I'm just going to be plain about it. These comments make you look dumb. And when we now have people with this proof knowing that this model is wrong now, and for the first time they're asking me, okay, now I want to know about your model, because they realize this is the thing that busts it, and it absolutely does. So let's take a look at some common sense, and then we'll go into the main thing in this video. Okay, let's take a look at this video that so many people have seen, and even as poor as I am with perspective, I can get this, but I need to point it out anyway. I want to ask the question, what is making the sun appear to rise and fall here? Okay, what is making it appear to rise and fall? That is the question. And the answer is simple. It's the tilt of the camera, because it's being tilted up and down by the wind here. It's being tilted up, the sun falls. All right? It just got tilted up more. When it's tilted down, or tilts down, the sun appears to go up. And so does the earth, correct? Any object that has no apparent background behind it is susceptible to this. Now, an observer on the earth, as it tilts, causes, according to science, the sun to rise and fall. And this is why in their model, as you're going to see, the sun is highest at noon and lowest at sunset. So let's get into the video. Okay, everyone. Hopefully this animation series here is going to help everyone get this. Let me go ahead and orientate you with what the screen is here. What we have is people out on the deck observing where their surroundings. This is what you would see on the earth and why you would see it on the earth. So we're going to start with the sun in the east and set in the west, as it always does. We're going to start at the northernmost part on the earth, and we're going to start on June 21st, which is the summer solstice, which is the day that the sun is directly above the Tropic of Cancer. Here's the equator, Tropic of Cancer, the next meridian line, and then the Arctic Circle. Equator, Tropic of Capricorn, the next meridian line, and the Antarctic Circle. So the sun is directly 90 degrees out from the Tropic of Cancer. This white arrow in between is nothing more than to show you if this arrow is going up or down, because it is hard to tell, especially when you're near the poles on the solstice. It gets easier to tell as we drop down, as you will see. So it's just a reference for you to note if this arrow is actually dropping down or going up as the day goes on. As we discussed earlier, we're going to start with the sun on the summer solstice to the right of the Earth, which is a valid model. The sun, the northern hemisphere is tilted towards the Earth, and it spins this way, okay? And as it spins, when you get to, let's call it 6 a.m., or roughly near there, you go from darkness into light, correct? When you come into light, you're going to travel during the day, and then at this point here, it's going to be 12 noon. Then at that point, we're going to drop down, we're going to act like we're flying to the other side to observe the other side of the Earth, which will swing the sun around to our left. Earth is still tilted towards the sun, northern hemisphere is still tilted down. This is perfectly 100% in line with the model. We're just looking at it from two different viewpoints, which they never show you. So we're going to look at it like that. Again, we're spinning this way. So we're going to start at 12 noon, where you're closest to the sun, and then we're going to go to, let's say, 6 p.m. or whatever it is. In the northern hemisphere, probably be closer to 10 or 11 at night, actually, this far north. But in any case, we're going to go towards sunset. And start up here, the arrows, there'll be little green arrows that come on here to tell you which one to look at. So let's go ahead and start the animation and see how it looks. So again, we're going to start up at this one at dawn, and these people are out there looking at it. I'm going to run through this twice so that you can, if you want, look at this the first. Actually, no, I'm not going to run through it twice. You can go back and view it the way this does, and then view the sun if you want. And then maybe you can see how both of them work at the same time. So here we go. Here's the first animation. You see the sun is rising, okay, and at the same time, the person positioned on the Earth, you're the camera. You're dropping down in your position on the Earth, correct? Which makes the sun rise. So I'm going to stop the animation there. What just happened? Actually, I will go back and do it again real quickly here. Let's run it one more time. Whatever one you looked at, look at the other one this time. Your position on the Earth at dawn starts here, and as you will see, it's hard to tell, but you do actually drop down because of the tilt of the Earth. Okay, we will deal with the perspective aspects of how far away this is after the animation. So let's go ahead and run it one more time. Your position dropping on the Earth, causing your view of the sun. The sun apparently is rising in the sky. Why? Because you have dropped your position. And this is the science model. This is exactly how they say it works. So it doesn't matter if we have the scale right or not. It shows what goes on, whatever the scale is. There will be a 3D model of this, guys, to scale, and you will see it. It's coming. Again, the scale doesn't matter. It amazes me, people that say it's not the scale, but they'll believe the exact same diagrams I showed in my first video provided by science, which are nowhere near scale. And they'll believe, oh yeah, that's how the seasons work. You don't need to see it to scale there, do you? Anyway, you will. Anyway, this is what you observe, and this is exactly what science says happens. So now we fly around to the other side of the Earth and come down here. Now we're looking at it. The person is still at high noon. The Earth is still turning the same direction, but we're going to head towards the dark side of the Earth now. So let's watch what happens there. The sun starts to go down as you move up. See how you're separating from the white arrow over here? And then the sun sets in the west, just like it should. So hopefully that makes sense. That's the first animation. I'll be talking less through these other animations. I'm not sure if I'm going to show all these. I'll probably show 2 examples in the north, the equator, then 1 or 2 in the south. It works the same both ways. It works the same both ways. People in the last video said, you didn't do the south, so it doesn't count or it's not right. I did do the south. I did the north and the south. I don't know what video they were watching, or they quit watching early, something like that. Anyway, let's go on to the next one. Okay, here we go again. I've decided to go with the Tropic of Cancer since that's exactly where the 90 degrees parallel to the sun is on this date. So we're going to watch us from sunrise on this portion of the earth spin, as we do, towards the sun, okay, and in an anti-clockwise manner. And then when we get to this point right here, we will be at noon. Then we will switch our camera position to the back down here, and we will pick it up at noon and go from there to sunset. Now notice the arc is much higher this time because we are now at the highest point where the sun is on the earth on this date. So let's go ahead and run this so you can watch it. Here we go. There's the sun rising as you on the earth, you here standing on the earth, are actually moving down and being tilted down by the earth. Now what happens? We get to we get to noon, correct? We get to noon. And the arc is much higher this time because we're much closer. You know, Neil Tyson deGrasse would love this. He'd be like, Rich, this is exactly how it works. This is the science model. This is exactly how it works, guys. Whether this is to scale or not, it works perfectly. Scale has nothing to do with this. Neither does temperature. I don't even know why that came up. You need to study, guys, what causes, according to science, difference in temperatures on the earth. And it's not because we're 6,000 miles closer from this point to this point, which is what somebody said. Okay, so now we're going to pick it up. Now we're on this side. We flew around to the other side of the earth and we're viewing it from this perspective. It's noon where we are, right here. All right, and what's going to happen is the earth is turning and it's heading towards the what? We're heading towards sunset in the west. That's why I have west on this side, east on the other. Both poles are pointing to north. Okay, we're always pointing at Polaris. We're just seeing it from the opposite side, guys. From noon to sunset, we're heading towards the west. That's why I have the west on here. People get hung up with there's no orientation in space, north, south, east, west. Yeah, but you're heading towards west on the earth. So earth is your frame of reference here. The sun rises in the east, moves to its high point in the day. Then from the high point in the day, you move towards west. Okay, the sun sets in the west. This is how it works. It has nothing to do with up and down in relation to space. It has to do with your position on the earth in relation to the sun. Your position on the earth in relation to the sun. Okay, now, can you predict what's going to happen here? The arrow is going to go up, which means the sun has to go down. Tilts up, sun goes down, appears to go down. So let's watch it. You see what's happening on both sides of the model? This is perfectly what science says happens. No doubt about it. And there we've completed it. Okay, here we go. We're going to do the equator this time, which is right here. Remember, the sun is right above the Tropic of Cancer on this date, rotating counterclockwise, which is the official science model. And what we'll note here is that the position of the observer on the earth as it moves from sunrise to noon is tilted and heading down, both. And if you're tilted and heading down in your viewpoint and you're looking out at the sun, it would necessarily have to rise, just like it does in a balloon if it tilts backward, the camera. You're the observer. So let's watch now. Even though we have now passed below where the sun is at 90 degrees, we get the same effect. It drops and the sun should rise. So let's watch that. That's exactly what happens. It drops and the sun rises. Just like that. And now we hit high noon. And what do we need to do now? We need to fly around to the other side of the earth and watch it from noon until sunset. By the way, I've changed the terminology here. This is sunrise perspective. And on the other side, it's going to be sunset perspective. so you don't get hung up with directions. Sunrise perspective, because this is where you see going from dark to sunrise and then to noon. And then on the other side, we go from the other way, we go from here we go, sunset perspective. As you can see, on this side, even though it's in the southern hemisphere, it's doing the same thing, isn't it? As it rises up, what's the sun doing? It has to fall to from your perspective. This is all perspective. And this is exactly how science explains it works. Now I'm going to do one more in the south, and I'll probably pick this one right here, just because it's far enough down you can see that it's going to work the whole way. So let me go ahead and do that one more, and then we are going to look at the winter solstice. And here we go. I'm having a blast, guys. I really am, because it's so over. Right here, okay, we are using this right here, which is the last meridian line I have marked. It's between the Tropic of Capricorn and the Arctic Circle, so it's right in between those two. And as you can tell, the tilt and direction will be down. Whenever that happens, if you tilt down, the object has to tilt up in perspective in relation to you. And this is exactly, video after video you can look up exactly how science says this works. This is why the sun appears to rise and have this arc, and why it's higher when it's closer to this area, and blah, blah, blah. So I'm using their own model. You can't debunk it. Let's play it through. Enjoy. Yep, you're tilted down and facing down, and you're going further down as the day goes on. And according to science, all over the place, go to Wikipedia even, this is what causes the sun to rise. Then you get to the top point, we fly to the other side, and guess what? You're heading up now, so that causes the sun to appear to set, even though the sun really isn't moving at all in their model, at least not around the Earth. We're the ones spinning, right? So there you have it set. And so that's it for the side. Now, let's switch to the other side, dun, 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 which is the winter solstice. Okay, just as a reminder for the science model. Just a reminder now. Now you can find probably 75 to 100 videos on YouTube that explain this, and all kind of science websites. Okay, I'm calling this, for lack of better words, the solstice mirror flip proof, because that's exactly what it is. Because their model requires you would have a flip, okay, of the light on the Earth. Okay, could be the solstice light flip proof, either way. Has nothing to do with time or the sidereal day, has nothing to do with temperatures, has nothing to do with the distance. I even use their model, made us slightly closer in the winter. How come we're not hotter then? Ugh. Anyway, so here's their model. Both of them turn counterclockwise. Here is Polaris that it's pointing to. Here's Polaris that it's pointed to. And here we start in June, okay? And as the year goes on, blah, 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 we come to the spring equinox. Wait till you see how freaky it is. You think this is going to be bad? Wait till you see this one. Oh, boy. Anyway, June 21st. Then in this position here, it is the fall, or the autumnal equinox, September 22nd. These are all within 1 or 2 days here. Then we have the winter solstice. And again, they reverse engineered the time, but they can't reverse engineer light hitting the Earth. Because at some point in the day, doesn't matter what time it is, you got to have sunrise, you got to have noon, and you got to have sunset. So there's no way around that, folks. You got to have it sometime. You mean, do we never have sunrise in the winter? Sometimes you might think not, depending on where you live. But anyway, that's another story, isn't it? And then the Earth proceeds around to the spring equinox right here, and then back again. And it's 365.25 day stupid cycle, which is now blown out of the water, as you're about to see. So now we're looking at this model here. We just got finished looking at this model. Okay, since there's no up and down in space, I guess, yeah, I'm going to put the sun on the same side. It makes it easier for me. You know what, speaking of which, in the same, I think it was right back to back, there's no up and down in space. And then the next thing was, yeah, but people up under the equator are upside down. It's like you can't, you just can't believe it. You can't make this stuff up. So let's get on with this proof and get rid of this stupid, stinking globe forever. Forever. It's gone. Guys, download this video, please, in case something happens to my channel or me or both, because this is it, guys. This is it. And it is it because this is their model. This is how they say it works. Look up how does sunrise and sunset work on the Earth? What creates the path in the sky? Look that up. This is their model. Exactly what I've been telling you. You tilt down, it rises up. When you tilt up, it goes down to the horizon. They never explain it from this perspective, though, and that's what you're going to see right now. Okay, guys, this is how it would work if their model was true. Wait till you see how preposterous this actually is. It's so preposterous that I didn't even want to believe that we could have been fooled this badly, because you're going to say, well, that's impossible because you just have the sun popping out of nowhere. That's correct, you would. One or two people picked that up on the first videos. So here we go. It's the winter solstice. Here's the sun over the Tropic of Capricorn, exactly the way science says. And we turn towards sunrise, okay? And guess what? We rise up, which means if you're rising up and tilting up, what happens? The sun appears to go down if you're going up. If you're tilting up and going up, the sun has to appear to go down. Correct? Here we go. This is exactly what we would see on their model. And they cannot reverse engineer it. They have way too many videos showing that this is it right here. Okay, let me back this up just a hair here. There we go. Okay, you would rise up. Okay, this is their model, guys. I'm just taking their model. No one has actually bothered to think what this would do to the sun in the sky. As you tilt up, just like tilting a camera up when you're out on a balloon, everything you see drops, including the sun. Remember, when it works in the summer, that's how science, all the videos you're going to go and look at after this, those of you who don't believe, say that it is the tilt, us going down on the tilt, which makes the sun go up in our sky. So the reverse has to be true in the winter. And here it is. So let's continue it on. We fly around to the back side, okay? And where is it? There it is. Look at that. Sun goes up as we tilt down, correct? No doubt about it. We start here. I didn't put the little arrow there. I think you can see that we fell. You start at the noon position, at the highest point of the day relative to the sun. Then you tilt down, which forces the sun or anything in the distance that you're viewing to go up. This is why you see Polaris, okay, and then the stars around it, like the Big Dipper and things like that, they will appear to dip and rise, okay, depending on what time of the year you're looking at it. One part of the year they dip, the next part of the year they appear to rise. That's because the other part of the year, when they appear to rise, we're heading down. It works with the stars. It also works with the sun, so they didn't reverse engineer it correctly. They didn't even think of this, I don't think. All right, so that's the Northern Hemisphere. It's busted right there. I don't even have to show you any other, but I'm going to. Let's go to the next one. Okay, now we're looking at the equator. Again, winter solstice. The sun is over Tropic of Capricorn. We're still rotating counterclockwise. The pole is still pointing up Polaris. We just moved 6 months from last time, that's all. Now we're going to start from the lowest position of the day, okay, at sunrise. And we're going to head up to noon, which means anything we see without a background is going to fall. Even with a background is going to fall, appear to fall, until we get to noon. So let's take a look at that. Same thing. Now I'm not changing the arc here on any of these because it's stupid anyway. You know this is a fake model that they came up with and they slammed us with for the last 500 years. Well, it's gone now. At least I hope so. At least I hope so. For those of you who want to just leave comments, see, it's debunked. Look at the other comments. Nobody debunked this. Nobody debunked this. So let's continue on. The sun would now be at the lowest point, as we see in the sky, because it's noon. So let's fly around to the other side of the earth and see what we got over there. Well, we started out at the highest position of the day, heading down, which means the sun has to travel up to, from our perspective. Has to. Has to. No doubt about it. Again, the stars that go around that don't rise and set, this is exactly what we see with the change in 6 months, right? Like the Big Dipper might be over here, like I said before, and it'll appear to rise for 6 months, and then it's on the other side that 6 months later and it appears to fall. This is what would be a necessity for the sun. I'm sorry, but that's just the way it is. We'll do one more. Okay, here's the last one. Still sun at the Tropic of Capricorn. We're going to go by this meridian line between the Tropic of Capricorn and Antarctica. And we're going to start at sunrise with the sun highest in the sky because we are at our lowest point. We're going to head up, which would bring the sun down as we look up and are tilted up during the day as we head towards noon. So let's watch that happen. Again, this is the winter solstice, December 22nd. Just like that. It's what we would see. If you want to believe their model. You still want to believe their model? So let's flip around to the other side. Same thing, okay? First meridian below, Tropic of Capricorn. Has to work this way. Now from noon to sunset, remember this is sunrise perspective, sunset perspective. All we do is we start out on this side and fly around to the back and look at this perspective. This is going to be much clearer when we do the 3D modeling, but this is the best I can do for now. So, as you as an observer looking back at the sun, okay, what are you doing? And of course the opposite is true. From noon to sunset, okay, you are heading down, tilted down, going down more as the day goes on, which would cause the sun from your perspective to rise in the sky. There is no way around this, okay? There just isn't. Let's play it. Okay, so that's it for now. Please share this video. Play it anywhere you want to play it. Mirror it. This is it. This gets rid of the heliocentric model. Then, once you realize that's gone, you can start looking at everything else, and then you'll realize the shape has been a lie as well all these years. So, again, you've got scientists that agree with us on this, and science agrees with this model because this is the one they gave us. Didn't I show you that at the beginning? Sure enough. All right, guys, you take care. Thanks to all you guys who have hung in there all this time waiting for something just absolutely they cannot take back. It's all over the internet with videos, science sites, how this sunrise sunset thing works, and they only show you the summer solstice with the earth pointing towards the sun. They never show you the winter. And now you know why. Take care, guys. Bye.